and welcome to everyone to this first meeting of the IEA Wind Task for forecasting. And we're having quite some changes. One little change actually is the number that we're changing from 36 to 51. We're getting into the third phase of this. But another big change is that so far we've been mostly looking into wind. And now for the new task, we're going to look much broader and look into much more of the total energy system. First of all, of course, the power system. That means we're looking into solar, we're looking into hydropower, we're looking into biomass as well. But also then what to do with all those electrons, looking into hydrogen, for example. So we're having a talk from the hydrogen TCP a bit later on. With that, there's also a new lineup of names, but I'll be coming to that a little bit later. We are having this agenda for today. So that's me and the introduction of the operating agent. I had the honor of being your operating agent for the last 6 years, and now I'm getting the chance for another 4 years. And with a bit of luck, we're also getting an extension, because I don't think that the challenges of forecasting are going to be solved in the next 4 years. So we're probably getting an extension there. And then we are going to have quite a number of, first, the adjacent IEA wind tasks. So that's farm flow control, which needs minute scale forecasts. That's Lidar, which aids in doing those minute scale forecasts. It's a talk from Airborne wind energy, where no one really has looked at what is going on in those heights where they fly. We're going to look into hybrid wind power plants, hybrid meaning with solar and batteries, followed by a probably very short coffee break, just for restocking of coffee. And then we already started with a little bit with solar and the hybrid power plants, and we'll go outside of IEA wind as such. So then we'll get to a talk by Remund on PVPS task 16, where he's looking into the solar resource and also into solar forecasting. We had invited the Hydro TCP Annex 9, but unfortunately they couldn't find someone in time. So we're dealing with what they can bring to the table, hopefully at the state-of-the-art workshop in summer. But we're having a talk from the hydrogen TCP and from the bioenergy TCP, and round that off with a talk from the World Meteorological Organization study group on integrated energy services, because there's a lot of synergy to be had with external partners. And then we are closing that at a quite late hour in Beijing. At the moment, it's good morning to those in the US. Actually, again, these 2 days, it's a Happy New Year to the Year of the Tiger to China. Then for tomorrow, we're going through all of the individual work streams, and we have a bit of changes in the program here. But that's relatively small changes, because the minute scale forecasting and proof-of-judgment doesn't have time before later on. And Jethro also had some, I think it was teaching, where he didn't have time in the original time slot. So we're taking those a bit later, and then the rest of the program is going to shift a little bit, but we'll see to that tomorrow. A very short introduction to the IEA as such. The International Energy Agency was founded in 1974 as a OECD country response to the oil shock and to the sudden realization that maybe all this energy use that we are having in the industrialized countries isn't really sustainable in the long run. While long queues at petrol station were the images associated in the US, the car-free Sundays were the ones more typical for that era in Europe. And to be able to further the development of programs that could wean the OECD countries off oil and gas, the IEA also started a lot of technology collaboration programs, some of which we are going to meet today. And one of them is the wind energy systems, the wind TCP. Within wind, we are having most of the countries that actually have significant installed capacity. India has just joined recently, and the Task 36 members. This time we're actually getting Sweden back, which I'm really happy for. And maybe we'll also get India in the medium run. So let's see what we get. There's a whole lot of different wind tasks. I don't want to get into details here, but we'll also see some more of those. And the general flow layout, I've shown that a few times before. So also in very short, typically we need weather forecasts and online data that goes into some sort of a power curve, grid companies or traders. And typically you get more of a probabilistic forecast in the end. And this is how we also structured our work packages, because we have all these different stakeholders, typically the meteorologists, the practitioners and forecasters and forecast providers, that whole undergrowth of companies in work package 2, and then we have mostly the end users lumped in work package 3. Development was that we started out as just taking a single weather forecast, putting it through the nominal power curve, and handing out that result to the utilities, to probabilistic forecasts in the early 2000s, where we also had for the first time something that looked a bit closer into how the industry actually collaborates. And then we found that these probabilistic forecasts worked best if we actually had the whole chain programmatically closed to the end user's particular problems. And that was sometime later. And now it's gotten over the last 10 years or so into dedicated forecasts for dedicated problems. And there's a whole lot of publications. When I was writing the state-of-the-art report here in the NMOS Plus project in 2011, the ambition was to have nearly all publications ever written on wind forecasting in that report, and that was 380. And I think at the time there were about 500. Now I haven't checked most recently, but it's well in the several thousands, so it wouldn't be possible anymore. So the task structure as such, we also decided to keep for task 51. So we have still weather prediction, power conversion, and user forecasts, and have these 3 work packages, and because they align with the stakeholders. But I'll show you in a moment that this is only partly relevant for what the what we actually need to do. One of the things, very shortly on the results of Task 36, one of the things that we had was an information portal that we try to keep up to date with a list of meteorology masts where you can get online data and where you can check your meteorological model for the heights that you usually don't really get. WMO heights are 10 meters. Those are masts over 100 meters. List of open weather data. More and more institutes have gone over to hand out their data for free because it's taxpayer paid anyway. A short mentioning of current or finished research projects. There's a list with a lot of different research projects on wind forecasting, and I'd like to, if you're still having these forecasts, please have a look at this page and check whether your recent forecast project is on there, because we need to update that one in the new task now. Another thing that we did, and that is a activity that we are still trying to do, are those benchmark cases. We had one day in September measured by the WFIP2 project in the US with mountain waves, and a European case was 1 week from an offshore wind farm. And the analysis started for the offshore case and had a number of different model results plus the actual measured from the mast at Fino. But it's preliminary results and I don't want to go too much into detail. Another thing that is still pending is the nearly finalized recommended practice for the implementation of renewable energy forecasting solutions. That's one of the activities where we already had some collaboration with the solar task. And we are currently finalizing this one. And it should be coming out as a book. If you want to know more about that, we have a YouTube channel. If you look for IEA Wind Forecasting on YouTube, there's a channel, and there's one of those YouTube videos that we had at the end of last year that gives you, I think, 20 minutes, half an hour on what that recommended practice actually is. Another one of those videos is, goes about the gaming. That still is an activity that's going on, where we're trying by gamification to show how useful the probabilistic forecasts actually are over deterministic forecasts. As I mentioned, there's a web presence, IEA Wind Forecasting DK. We're trying to move that over to the central IEA Wind server, but that's an activity that will probably take a few months. And as mentioned, we got this YouTube channel. But now to the changes that happened between task 36 and task 51. We had a longer discussion on how to actually set up the task newly. And we came forward that quite a number of things have changed. One of the smaller changes, you could say, is the leadership team, because Helmut Frank and Will Shaw were the leads of the meteorology work package. Will Shaw has retired to the end of the year. He also was the co-operating agent. The co-operating agent is now Caroline Draxelt. John Zack were the work package leads for work package 2. Pierre got a new position, which he'll start in the summer. And so he wasn't available anymore for the next phase. And then we have for the end user work package, Gunnar Merlin, George Kraniotakis, and Ricardo Bessa, who were running that work package for a number of years. So 2 people less, 2 new people were coming. Jethro Browell, you know him from Strathclyde, but he's actually switched over to the University of Glasgow. And we're quite happy to announce David Lanahan from UK National Grid as one actual end user of the forecast. And since that is a bit unbalanced, Caroline, who's a meteorologist by trade, is now also co-heading work package 1 instead of 2. So the changes to task 51 were that in the olden days, we had a lot of central power stations, maybe hydro plant, maybe nuclear plant, and that was just getting power to the consumers. But what we now have sort of is that we get a lot of PV and wind and offshore wind as well, and that's making it a bit more complicated. But in the future, we're also getting rid of a lot of the coal-fired power stations. A number of the nuclear power stations are are reaching end of life or are actively shut down, like in Germany. And we're getting much more wind and solar, so plus electric cars, plus batteries. So the whole system is changing to smaller individual sizes, to inverter-based generation, and to a weather-driven energy system. And that's what came out of a brainstorming a couple of meetings ago. And then on the last meeting, we actually tried to have a sort of different structure. So you still see the work packages, because the work packages, as I mentioned, 3 is a good number. All these, I haven't even counted them, all this number of work streams that we have would be a bit too many work packages. But we have these work streams where in each individual, we also have indicated that we have a column from within the wind TCP, or like this one without outside of the wind TCP. And the individual work streams are going to be the topic of tomorrow. So keep your horses and wait until we get to those. Each work stream has a work package that it's associated with them, and that's sort of mostly administrative, because some are stretching, like the atmospheric physics and modeling, that's mainly in work package 1 and has a little overlap to work package 2, because if you want to convert those to power, you need to know what they are. But some others, state-of-the-art for energy system forecasting, for example, are going to be spanning all 3 work packages, and administratively they are just centralized to work package 2. And that is the only announcement of this here that I have. There's a workshop that we promised here, and we had a workshop like that 6 years ago when we started work at Task 36 in Barcelona. Some of you were there already. And that was a very good workshop that also had a paper at the end with the state of the art and especially the research challenges that we wanted to look at. I didn't go back at the paper to see what we actually managed to fulfill. That would be an interesting exercise to start that workshop with. And one of the things that we want to do here on this meeting is actually also preparing for this workshop. When, where, who should be organizing it, who should be in the organizing committee, and so on. But having said that, we're back to the agenda, and now we're starting the first of the several talks that we're having from the IEA Wind side. So I'll stop the sharing here and hope that Paulo is actually online.
Hey, can you hear me okay?
Hi, Paulo.
Hi, okay, good.
And Paulo is going to tell us about wind farm flow control. Paul, it looks like you're frozen, or is that just my screen? Okay, let's give him a second to come back.
Can you hear me?
Yes.
Sorry about that. Do you see?
Yes.
The slide screen? Sorry,
Yep.
It's not highlighting right. Sorry for the technical problems. Okay. Okay, great. Well, thanks very much for having me. I'm Paul Fleming. I'm one of the co-operating agents for the new wind farm flow control IEA Wind Task 44, together with Jan Willem van Wingerden of TU Delft. So this is us. And we cooperate this together. I think Jan Willem will be on the call later. So I'll just try to talk quickly about the new IEA Wind Task 44, and then make a few comments about how we might connect to IEA Wind Task 51. So the original concept around Task 44 was looking at progress made in technologies that we've called wind farm flow control to separate them from things like electrical plant control, and seeing progress from the wake research that was done, and then the first concepts of flow control technology like static induction control, yaw steering, dynamic induction control. Then in the more recent times, starting to see validation campaigns run, and then seeing on the development of the controls. Looking forward to the future, we hope the wide scale adoption and trust of these technologies. We saw maybe that here in the middle could be the IEA task proposal, helping to move from the state of the art as it exists across a few current research projects to getting to kind of community adoption and trust in the technologies. So helping to move from here to there. The purpose then of the IEA Task 44 is to gather ongoing research results as well as state-of-the-art in industrial practice, create an overview of control technologies and algorithms, and explore how uncertainties affect the performance and potential for adoption of wind farm flow control. The result is guidance for the wind industry and research on the current control algorithms, requirements, impediments to adoption, future directions, and expected benefits of wind farm control. And the work itself is divided into 4 packages. In the first work package, we track the evolving state of wind farm control, conduct expert elicitations, and we help develop a set of recommendations and best practices. In the second work package, we try to characterize sources of uncertainty, develop methods for estimating AP loads with overall uncertainty, and develop another set of recommendations and best practices about uncertainty. Work package 3 is characterizing the building blocks that define wind farm control and build an overview of available options, give a full landscape of the solution space, and finally work package to collaborate and coordinate with other IEA tasks and other wind farm control R&D activities. Based on tasks 1 through 3, external projects identify research gaps and develop a research roadmap. And so I'll just highlight work package 4, which is led by Tufay Gochman, as a clear place where we can interact with IEA Task 51. This is the leadership group. So I think another thing is that we will have people in common across some of these tasks. So some of these names are probably familiar. These are the people leading the different work packages that I just mentioned. And some of the centers involved in leading it. And then just to finish up, I wrote out a list of a few ideas for starting places for interaction with Task 51. So first, like I said, work package 4 is explicitly tasks with collaborating with other IEA tasks. So hopefully through Tufay and that team, there'll be a lot of interactions with Task 51. We're also hoping to soon have a public wiki page for collecting and disseminating research results in the wind farm flow control space that'll be open. So there, I think, will be another space for interaction and collaboration. Then thinking more technically, wind farm controls which have the ability to act on forecasting information is perhaps a good first point of connection. And maybe we could think about interacting with something like the hybrid plants task and IEA task 50 in a similar way, thinking about when that becomes part of the inputs in farm controller. And finally, I think this could be a synergy between wind farm control actions such as online estimation of flow conditions from real-time plant data, something more like, I guess you'd call it nowcasting, trying to infer something about the flow ability to, one of the things that we're struggling with, and how that connects to forecasting out the future is probably another useful space for interaction. So that was what I had. You can reach out to me for more information on task 44. And yeah, thank you very much. Maybe I should leave this up. Okay.
Thanks, Paul. This was great. As you mentioned, yes, we have some overlap of personnel already. So that's great. We also definitely clearly have some overlap on what we want to do and what we want to achieve. So that's also very promising in terms of collaboration. Are there any questions to Paul? There's one hand up here. It's so many people that I can't really see who's on. John.
John Zach, is this on my screen?
Yeah.
Yes, Paul, very nice overview. I have one question. Can you give a real brief summary of what has been done on the interaction of forecasting and wind farm flow control at this point?
Yeah, sure. So I think that the reason I mentioned the hybrids is probably that's my best thinking about it, is when the flow control target has to do with something like tracking an AGC set point or providing a certain delta to the available power so that it has a certain amount of power in reserve, then the forecast becomes obviously really relevant. But to be honest, a discrete paper that I think my colleague Jen King has one, but I'm drawing a blank. I know I've participated in a lot of discussions about it, but I can't think of a study off the top of my head that's using. Sorry. If you send me an email, I know that Jen King has one, and I can't bring it to mind.
Okay, yeah, we can follow up offline.
Yeah, or maybe Sue.
Yeah, Sue. Sue, please.
Hi, Paul. Ideally, what time frame would you love to see forecasts on, and at what frequency?
Oh yeah, that's a great question. So I think that it will depend on what you're using the forecast for. So, we've talked about, let's take an example, right? So one thing that we're thinking about now is, in my research group, let's say, I'm not speaking for everyone doing wind farm flow control, is that wind farm, a topic like wake steering, performs differently under different atmospheric conditions. And so one way to right now, you just sort of, the tests that we've run, you just apply one controller based on the direction of the wind speed. But it would be better to adjust based on the conditions that are impacting how long wakes propagate for, or how controllable they are. This seems to come through, like if the wind direction is highly varying, it might be a good time to switch off the controller. And so one solution is, like I mentioned, like online estimation of the flow conditions. Forecasting and the information that comes from forecasting might be a useful supplement to that, to talk about when the flow is expected to be low turbulence stable, or highly turbulent, or very variable wind directions. That is just power maximization. So there probably you're looking at a fairly short horizon because the whole system can adjust in a minute. And so knowing something like that an hour out, I don't know what you use for. On the other hand, if you're dealing with wind farm flow control and its interaction to energy production, because you're trying to either track a power reference or you're trying to guarantee a certain amount of firmness for the plant, I think then it looks more like maybe 1 hour. Then it really depends on the objectives, what you're trying to do. But as an input to the controller, yeah, I think it will depend on the objectives. We'd have to map it out a little bit, I think, to give a good answer.
Okay, thank you.
Yeah, you're welcome.
Thanks, Paul. G?
Okay, thank you. Actually, I don't have any question, but I have one suggestion to the post task, because I'm also in the task 44, and I found that these two tasks have many collaboration, and for some field you have the overlaps, for the minute scale or second scale forecast and the value of the forecast. So my suggestion is how to do these two tasks, how to improve the interaction between these two tasks, because we hope that we could build up a better forecast model. I hope to get the results from the users, because the farm control is one of the user for the forecast, for the forecaster, not only the market and the system operator. And let us to know more about the value of the forecast. So my suggestion is to increase the interaction and more workshop or more reports for these two tasks to do together. Thank you.
Yeah, that's a great suggestion. So I'll take an action. I'll just write down some notes to share with the task leads, and especially include that comment. How can we organize something to get interesting? It's a great suggestion. So I'll follow up on that.
Actually, in the minute scale forecasting, we already have a common workshop, even though it's only relatively late. So it's in 2.5 years that we have it planned. But we're not totally fixed on the order of our workshops. And maybe you have a workshop that you are going to do where we can tie into it. Anyway, thanks, Paul.
Thank you, Gregor.
And the next speaker is David Schlipf. He's the operating agent of the Lidar task.
Welcome, everyone. So good morning or good afternoon. Happy New Year. And I'll also try to share my screen. Can you see my slides now?
Yes.
Okay, perfect. Yeah, so that's about the Lidar task, formerly known as Task 32. So we are somehow in between the tasks because we finished the Task 32 last year, and we got the new task approved. And we are currently now working on getting started. And at the moment, the most likely date to get started is the 1st of April. And we try not to talk about the task 32 anymore, but about the Lidar task. And here I would like first to present where are we today. So Lidar is already replacing 5 to 10% of met masts for resource assessment or on the operational wind farms. And those are like vertical profiling, but we also have floating lidars. And here they almost completely replaced floating offshore met masts because those are way more expensive. Then another really interesting application is the turbine-mounted lidar, which can be used for yaw correction, power performance testing, load verification, turbine and wind farm control. And this turbine control is very much related to the forecasting. So what's the Lidar market? So this is like an analysis made by Andy Clifton, and he just analyzed existing data. And this was done 2021, and it's already a bit outdated. But at this time, it was around 1,000 new Lidar units sold per year for all applications together. But I just got the news that in 2021, just for the control application of lidar-assisted control, there have been at least 1,000 turbines equipped, new turbines with a lidar for control. So like this number, for example, this was 4 times higher already last year. And here we see how we think the lidar fleet is growing over the next 5 years, so the time of the next task. Here you see like the cumulative units, and please consider that's the logarithmic scale. And here we have some data estimated for floating in blue. And for example, here in black, we see the one for the nacelle-based, and they are even increasing more than shown here, as I mentioned. Another 1,000 just in 1 year, just for controls, and also for other applications, we have nacelle-based lidar systems. Why do we think it's continued to be important, lidar? Is mostly because modern wind farm needs new methods and new instruments where lidar can help. So we have a larger induction zones, we have more blockage, turbines are changing, we have more flexible blades, wakes, taller turbines in general, and in most countries, wind lost subsidies. So it's also really important to become smarter and more adjustable. And this means we think that we need more lidars, and this will also raise more questions. So we need to build more or less 5 times as many lidar over the next 5 years. And here we need to transfer our expertise from the met mast, which is often still standard in resource assessment, to lidars. And also we need to simplify the use of lidars and to improve them as well. And therefore we applied for this new task. Hopefully we will be 52, then it won't be too much difference from 32. But anyway, don't forget the number. I think it's better to just keep this a task on lidar. And here the main idea is to make the wind plans of tomorrow possible. We also have a change in the operating agent. So Andy and me were operating the task 32. And now in the new task, Andy will swap role with Julia. I think Andy will still be involved in the task, but the new main operating agent will be Julia Gottschalk from Fraunhofer-Eves. We also have a new mission. So we would like to work together on research to make wind lidar the best and preferred wind measurement tool for the whole wind energy community. And our vision is that in the future, using lidar will be very easy, and it will bring advantages and opportunities to everyone in the wind energy based on our values. And we also have some new themes. So instead of work packages, we have themes here. And the most related to the forecasting, I think, might be the first one, which is on universal inflow characterization. So we would like to work together to get and use the best information about the inflow to any wind turbine anytime. And here the planned deliverable is recommended practices for light-assisted control. And we also hope we can do another expert report. It might be on TI, but also include other applications such as forecasting. We further would like to work on replacing more met masts, and this is especially important for complex terrain. We would like to make LiDARs more digital systems, and here work together with task 43. And finally, we think that floating LiDARs are really good to accelerate offshore wind deployment. Our task format is a bit changed now, so we try to focus more on this public-private differences and work in working group, but still have webinars, which work really great during the time of the pandemic. And the main challenge we have at the moment to transfer from task 32, which has a pretty strong name, to a lighter task. So we have to see how we can continue with our LinkedIn group, mailing list, and so on. And then we will also continue our collaboration with other tasks. For example, we are working with the cold climate. We have been working with the forecasting task here and also would like to continue. So the main outcome of the collaboration was our Energies journal article. We also worked with the systems engineering task, had this nice workshop, but also we plan a workshop. Paul, we have to talk about that again, about a LiDAR for wind farm control. Another great basis for future collaboration between the forecasting and the LiDAR task, I think, is Ina's Works PhD presentation. Here you can find the Zenodo link if you are more interested in the details, but the main message here is that LiDAR-based forecasts have great potential to improve forecasts in the minute scale. And maybe Ines can answer more questions to that later. But this is kind of a highlight also on this collaboration. If you have further questions, please don't hesitate to get in contact with either Julia and me, and also Andy. Now he's working for his spin-off, is still, I think, very much involved in the LiDAR world. So that's from my side.
Thanks, David. Do we have any questions for David? G?
Hello, may I have a question? My understanding that for the...
You're really hard to hear, G.
Hello.
That's better.
Okay. My question is, to my understanding, that the minute scale data or the second scale data is better to obtain, to measure the data in such frequency by the LiDAR. But in this task, do you have any research about how good, how well, or how different about the reliability and the accuracy of the measurement when we need to measure the data in such high resolution of the time? Thank you.
Okay, so I hope I understood it correctly. So that question was if we have some research on improving the accuracy of the measurements. And yes, we do. So we also want to improve the LiDAR system as such. And I think, for example, the LiDAR system Ines was using is a scanning LiDAR. So there's also some task planned on the scanning LiDAR systems.
Is it published or can be shared among the other to the other tasks?
I think the presentation here you can follow via the link. I can also post it in the chat. And we also have in our general meeting from last year, we have like the outline on how we would like to continue with our research. And there you might find this information. I can also post the Zenodo link in the chat.
Thank you. Okay, thank you.
Then there's a question from WEMC. It's probably Alberto.
Yeah, sorry, Greg. Sorry, I couldn't find the unmute button. Yeah, sorry. I was just curious to know whether there's actually also a MetMast task force. And I can see there is a lot of focus on Lidar, which is very good, but obviously you'll have compared with the huge amount of data from MetMast. I mean, it's historically, it's good to keep the history of the climatology, sorry, of the wind. Yeah, so presumably there's that you're working on ways to also extend and maybe back correct the wind mass data to improve the historical record.
Yeah, we had a really long discussion about all this Lidar and MetMast differences. And it's sometimes understandable that people still use MetMasts. And I think that's mainly because it's also a simpler device. But like the problem is they're not measuring the same. And therefore like correcting is always a tough word there. So before they thought, okay, we have to correct the Lidar, and now Lidar turns out to be a better tool for measuring, for example, like rotor averaged stuff. And yeah, then correcting a Lidar doesn't make sense, but on the other side, also correcting a MetMast is not fair because it's just point measurement. But anyway, I think we cannot totally replace the MetMasts. But maybe it's also a bit strong here to call this theme replacing MetMasts. So we also had a discussion on that. But I think the main idea is to better understand the differences and use the right device for the right task.
Thanks. Corinna has a question.
Okay, thank you.
Yeah, Alberta, did you want to say anything more? Oh, okay.
No, thank you. Yeah, I mean, it'd be interesting, but no, I'll leave it. Thank you.
Okay, so I agree to Alberta that there is this probably a longer lasting discussion that we have to have once in a in-person meeting. But I think one thing that I also missed and that we kind of would like to throw in here is the uncertainty in the measurements. That is a big deal also on the Lidar measurements. That's at least my experience. And we have G will be leading a work stream on uncovering the uncertainties. Then now we have been doing it qualitatively and we want to do it quantitatively. So I think this would be something where we really would like to have a foot into your task because that's an important, I mean, that's an important part when something should replace or something should be used in such a different way than MetMasts are, in the replacement. Or if you talk about replacement, then we also have to look into what are the uncertainties that we get with the Lidar in comparison to MetMasts and all that kind of data that also we want to use for the forecasting. So that's just an announcement.
Yeah, thanks. Yeah, I think the uncertainty issue is like evergreen also in the Lidar task. So we had a lot of discussions there and continue to work on it. And as always, like with uncertainty, it's question of the reference. And I think it's also important to think a bit more on references. But I totally agree that that's a really good topic to continue the collaboration between the tasks. Thanks.
Good.
Yeah, thanks.
And yeah, Vikram, is that a short question or
a very short question, Gregor, if I may. I think like since the point of uncertainty has been brought in here, but one of the other things I was going to ask, and this is probably also relevant for other aspects, is the imputation of data or trying to fill in the gaps of missing data. Do we have an agreement or at least some guidelines on what to choose, not what to choose, or work in that direction? Where do we stand there at this point?
Yeah, I think it's kind of included in like the use of Lidar should be easy in this main idea. And also, I think maybe in the digitalization theme, we will address this issue of this, making data more available and more easy to use to others. But I also really happy about any comments or things we should do as a task. So to make it more useful for other applications, because as I mentioned, that's our mission. So we would like to make our Lidar like the best and preferred tool for wind measurements in the wind community for all applications. It's really ambitious mission, but it also, as Gregor mentioned, so we hope for an extension. So we might have more time than 5 years for it. And therefore, any comment how we can make Lidars better for your application would be really welcome. So please write us an email, and then we can see how we continue to improve Lidars.
And with that, there's a very obvious leading into the next talk, because it's by Kristian Petrick from Airborne Wind Energy, from Airborne Wind Europe, and a MetMast in the flying heights of the airborne wind energy implementations is probably something that we're not going to see, but with the Lidars we can get there. So with that, Kristian, please take it away.
Okay, thanks very much, Gregor. And indeed, it's nice to have task 52 here just in front of me, because Andy was actually helping us with setting up this task. We are also really new. We just started in October. So I will share my slides and I hope you can see them. Okay, can you see the presentation?
Yes, now it's fine.
Okay. So I will take this opportunity to just show you a few slides about airborne wind energy, because many of you may not be familiar with this new technology. I'm a member of, or I'm working in the Secretariat of Airborne Wind Europe, which is the association of the airborne wind energy sector. And we are also the operating agent of this new task 48. So here you see our members, which are the main companies that are developing airborne wind energy systems. We are part of Wind Europe, and now also part of the IEA community, or IEA Wind community. Here you get an overview, an idea of the different systems that are being developed, ranging from soft kites, like large kite surfing kites, and up to rigid wing or fixed wing aircraft type, drone type kites. Some producing energy on the ground, some of them in the air, and then there are also other concepts that use the wind in different types of torsion-like machines. But the key principles are these two: the ground generation, where you have the kite flying out in circles or in figures of 8, pulling on a tether, which is wheeled up on a winch, and then by unwinding, you generate electricity with the generator on the ground. And then at a certain time, you have to fly back and rewind the drum. So this is called yo-yo principle or ground gen. And then you have the fly gen systems, where you have little turbines on board with a generator or motors in the wings, and then the electricity is evacuated through the tether. So these are the two key principles. And the idea is to emulate the wing tips of a conventional wind turbine and get rid of the tower and the blades, and thus reduce the amount of material that is actually required. And that means that by getting rid of large parts of that material, we can reduce the capex, which should in the medium to long run help us to have lower LCOE than conventional wind. This is still to be proven, but we are quite optimistic that by 2030, roughly, that should be the case. The other big advantage is that we can capture wind resource in higher altitudes. You see here wind speed at 100 meters above ground on the left, and wind speed at the optimal altitude between anything between 0 and 500. So not all the time the wind is really the highest at higher altitudes. And you see that then large parts of Europe actually become interesting, or really with excellent conditions above 7 meters per second wind resource. And by combining that with a potential higher capacity factor, we should, as I said, have a lower LCOE. Hopefully, we think with flexibility and scalability, we can also get into new markets. For example, repowering float offshore systems, the first ones, and then also floating offshore, because we don't need all these big counterweights. So future, well, that's still a few years out, but then you could imagine these platforms from where the kites are being started in offshore locations, but then also in hybrid systems or remote locations, or any area where you have a little bit of space. It should be possible to fly these systems. We will then also later see how safe they are if you can actually fly over sparsely populated areas. Yeah, and I mentioned the niche markets. So now the interesting thing is that last year, SkySails Power introduced the first commercial systems. So these are kites between 100 and 200 megawatt, sorry, not megawatt, kilowatt. So comparably small still, but they're working already on the first megawatt kites. But now these systems, the small ones here, are being commercialized, and they are already competitive with diesel generated power. So it's we are around 20 cents, or we are already below 20 cents per kilowatt hour, which is quite promising. So we hope that we will also get the policies and regulation done in Europe to have some deployment also here in Europe, closer to where the companies are. Because yeah, we are global technology, but most of the activity is taking place in Europe. But the US is also quite active now. Has been active with Makani, but then Makani, a Google company, was shut down. But now NREL seems to have again interest in this technology. And yeah, I mentioned that we are now this new task. We have currently 9 member countries. We started in October, and we have now started the different work packages, just also kick-off meetings over the last weeks and months. We have these 5 work packages, and the most interesting one for task 51 collaboration would be the first one on resource potential and markets. But then, yeah, we have also metrics and tools, which is kind of partially overlapping when it comes to simulations and stuff like that. Then safety and regulation, public acceptability, and different airborne wind energy system architectures. So this task, or this work package 1, is being led by Roland Schmeel from TU Delft, and I asked him if he could join this meeting, but unfortunately he was not available, because he could talk much more about the things they're working on, or that he has in mind to develop in this work package. Just here, the overall goals. One would be to develop a global higher altitude wind atlas for up to 1 kilometer. So that's one of the things that I would also convey to you. Please consider airborne wind in everything what you do now with regards to forecasting or Lidar or what it be. At least up to 500 meters, ideally even higher. But yeah, at the moment, the kites would fly maximum 500 meters, basically. But it's important to keep this in mind, that there's a technology that goes higher than even the large wind turbines that we are going to expect. Then they are working on a techno-economic tool chain to really see also what is economically viable in the end, and do this also on a wind park level and integration to future energy systems. So I just took a few slides from Roland here, where you can see that they work, for example, on these wind profile shapes using ERA 5 data and Lidar. They said it's still expensive and there's not too many data yet, but it seems to, as David showed, to increase now in future, hopefully. And then with these wind profiles, they put this into some kind of tools and create these graphs and make calculations and see how the power curves how this can be linked to the power curves and what the actual output of energy then will be, and with the respective costs. But please don't ask me anything on this, because I really can't answer too much on that. But then, as I said, the necessity to go into the or beyond levelized cost of energy and to capacity factors, the purchasing or the purchasing costs basically of electricity, voltage regulation, and other design drivers are becoming more and more important, also to be considered for airborne wind. And with that, and again, the call to please do not forget us. I would ask now, or basically stop this presentation and try to answer any questions that you may have. And as I said, with task 51, I assume that some of the participants in the work package 1, Roland and others, will get in contact with you guys and see where's overlap. And I assume some people here may already be in this meeting who have also been part of our work package. So yeah, thanks very much again for the opportunity to let me present Airborne Wind Energy. And happy to take any questions.
Yeah, thanks for coming. I have to say, it had been my impression that it was a technology that still was quite far away from the market. But when I saw it on the last EXCO meeting of the IEA Wind EXCO, and you presented that there actually were systems that were commercially available, and that there's such a broad range of systems being in the market, I thought, well, maybe we should actually start preparing for implementation in the market.
Exactly. Yeah. No, that's really the message that I want to bring. That, I mean, yeah, many of the companies that you have seen are still 2, 3, 4 years away from getting their system into the markets. But especially Sky Sails, Kite Power, another soft kite company, and MPIX in the next 2 or 3 years will have their 100 kilowatt kites available. And yeah, they are not that expensive anymore, or the kilowatt hour price won't be that high. So indeed, we are there at the brink of commercialization. But then there are a few questions. I think Helmut was first, I'm sure.
Yeah, hi, thank you for the presentation. I want to come back to when you say what are the corporations here to this task. And so this task is not so much about resource assessment, but about forecasting. So I want to ask you what you think about what are the special things about forecasting now for this type of wind energy plans. Is, for example, my question, do you think turbulence is more critical for these systems than for tower turbines and towers? Also, I could imagine that low winds could be critical. I mean, that at very low wind, the system has to stop and then it has to safely land. So what do you think?
Well, I think the turbulence is a very important thing because it's already quite complex to fly in steady winds, but then the system has to really always find the best way and react very quickly to turbulences. So again, I'm not really the expert in that, but I know that one is definitely an issue. I don't see so much the issue of low winds because if there's no wind, in the worst case, the kite just dives down and lands. And once the wind picks up again, it starts again. So that's actually not an issue. Just, yeah, you don't produce during that time, but landing, all that will be automated and is already largely automated and can be done very quickly. So that's not the key point. It's then, yeah, I think the turbulence, any kind of these gusts, change of wind direction maybe as well, I'm not sure. Yeah, I think these questions would be rather for Roland than for me. I'm sorry that I can't say too much on that, but we also, to make the business case for airborne wind, it's very important for us to really know what how often we can fly and how long we can fly. And at the moment, we assume that we will have high capacity factors, but only a few companies really do 24-hour flights.
Thank you.
And I'm not sure who was first. Corinna, maybe?
Okay, let's just take Corinna.
I think it was John.
Anyway.
But I'll start then. Sorry, John. Yeah, I think we will probably have something similar going into the 500 to 1 kilometer height, like we had when starting offshore. It seems like there is maybe more steady wind, but this is probably will not be the case. But I have a question maybe to everybody. Maybe a bit stupid and out of date, but do we know how the translation from wind to power is in the airborne wind, or is this still a research or nobody looking into this, or is it the same? Is it kind of similar to what we have in the normal or the wind turbine area with the power curve?
Yeah, no, we also have power curves, and that's something that is being looked into. I didn't show the other slides there, but basically what you take out of these wind profiles, you combine them with the potential power curves, and then you simulate and then you evaluate. So these kind of processes are going on. There's also quite a lot of research going on how to really translate wind resource into power.
But does the power curve look very different to a wind turbine, or is it kind of similar?
No, that's in general similar. So it goes up and then it flattens out, and at one point it drops again. Okay. So that's in general, yeah, depending also again on the kite, but they can start already by lower winds, and then it depends on the kite size.
Okay, thanks. Very interesting. That's definitely something we will have to collaborate on, because that's the forecasting of that will be an important part for the coming on the grid, I guess.
Yeah. John?
Yes, very interesting. I'm wondering, what are the characteristics of the behavior in extreme weather conditions? So, the ground-based turbines, you have the high-speed cutout, you have the high temperature, low temperature issues. So what are the limitations of these systems in extreme weather conditions?
Well, overall, they can fly in pretty high winds, and if it's getting too high, then there are cut out wind speeds where the kite has to land. But they could also go into a hovering position and just wait until it's getting better again. But I think for that one, for example, forecasting may also be interesting to say, okay, is it worthwhile to go down, or is it just a short increase in wind and then I better stay in the air? That I could imagine. So, but yeah, whoever has done kite surfing knows that even if you are overpowered, you can just basically hover the kite and stand out quite a lot of it. And if it gets too much, then you land the kite. And here we see the advantage for hurricane regions as well, or islands that are where you can have really, really high wind speeds, that you can just land the kite and pack it away, really stow it, and then nothing can happen to it.
Hey, how about precipitation with, say, heavy rain or snow or icing? I assume you have some issues
Or lightning.
there.
Yeah, yeah. All this is still being worked on, and I think there are no real good solutions yet at the moment. If there's lighting problem, or if a thunderstorm comes in, then as far as I know, everybody lands now, and really. There were test flight and demonstrations in rainy conditions, so that seems to work, or yeah, to a certain extent at least. I think in wind and ice, not too many have flown yet. So yeah, there's still lots to be done.
Thank you.
Welcome.
Kaushik?
Yeah, I am also going to ask more a very ignorant question, but I was wondering, what about the auxiliary devices requirement?
Sorry, I didn't get the question. What?
Like, do you need a battery storage? Do you need for a airborne wind energy system, like a battery storage to start it up and shut down? And is there any research ongoing on?
Yeah. Well, you have the systems that are these yo-yo principle systems. They will most likely have an energy storage in the ground station in order to buffer the peaks, because you will have high peaks in energy generation when you do the turns. And then, but the average power will be lower because you fly them in again. And to buffer that, there may be hydraulic storage systems or battery storage. That's still to be seen. So what? Yeah, there will be most likely some kind of storage. The other kites that, or some of the kites have small batteries on the plane for some maneuvers or for starting, like the MPEX one, and then the ground, the flygen systems. I think they have small batteries on board, but they can also, if really necessary, get the electricity through the cable to the kite itself.
I think that's very interesting, and I mean, this is very much then relevant also for task 50, where we are like hybrids, where we are looking at wind plus storage as well, and then the storage lifetime and storage degradation models and things like that are of relevance. So this is probably a point of interaction with task 50. We can look in.
Thanks. Yeah. Thank you.
Martin?
I'm just looking at the time because I was already over time a little bit, but Gregor, you have that under control, I hope.
Sort of.
Oh, okay, good. No, that I don't want to take too much. Yeah, no, please, Martin.
Thank you. I'm just like Gregor. I'm fascinated to see that you're already pretty much along the way towards commercialization here. At least the technical points seem to have been figured out quite well. I was wondering about the regulation, because setting up just a normal wind turbine in Germany next to even a little airfield gives you hell to pay as far as regulation is concerned, and or flying a drone that is heavier than 2 kilograms, something like that. So I'm wondering, what is your target areas where you would like to fly these things? Because I think over populated areas, it's probably not a good idea, is it?
No, it isn't. No, that's what we don't want to do at the moment. So what we need kind of is, for example, the SkySail system, an area of about, from the ground station, a circle of 800 meters radius, 800 to 1,000 meters, and yeah, not populated, but it can be fields where you can still have people working on the fields potentially, but not too many. And the regulation is indeed something that we are also working on. We are kind of a middle thing between a wind turbine, an obstacle, a balloon, and a drone. So there is a lot of regulation out there, especially now with the new drone regulation or unmanned aerial systems. There's a lot that we can, especially when it comes to risk assessment and mitigation, we will take over from there, or already in processes like especially the rigid wings, they use these regulations as guiding ones. But in Germany, for example, there are now cases where the municipality or the administration there said, okay, no, we don't see you too much in the air, so basically we don't use and go the BIMSCH, our federal emission impact regulation, or what it's called in English. We don't need that process, but you're just a building basically, and then you have to make sure that you can fly above it. But the process itself, you just go for building regulation. And so we are kind of in this middle thing, and depending on the kite system, different regulations will apply, also depending on how the specific public authority deals with it. But this is work in progress. It may go into one direction or the other, and also depending on the kite system may change. But our idea is that currently the systems are flying in airspace that is really blocked. We don't want that. We want to be like a wind park, that the others know that we are there, that we are flying there. And maybe use also ideas of that we can dive down if a plane arrives with, like you do now with bird detection, transponder stuff. That's the idea. So we want to integrate into the airspace like other users.
Okay, thank you.
Welcome.
Very interesting.
Good. And with that, I think also in the sake of time, I'm giving the word over to Kaushik, who already is on, who will tell us a bit more about the hybrid wind power plants. And it seems like the airborne wind might actually be in the medium run also a contender to be part of the hybrid wind power plants.
Yeah,
hopefully.
Yeah. We had some discussions with some people around NDTU at some point as well. So yeah, I definitely see that's possible. Thank you, Gregor, and thank you for inviting. And so this is one of the newest tasks, along with Gregor's, the task 50, which is about hybrid wind power plants. And this is both Jen King from NREL and myself have got the opportunity to be the cooperating agents for this task, and we are planning to have the task kick off next month in March. So if you are interested, please write an email. Anyway, I'll try to invite all the tasks there, but if you do not get an invitation through the task or somehow, please feel free to contact me. Yeah. But talking a little bit about the background, so the need for hybrid power plants is that it increases the flexibility of renewable generation, increases their availability, but also provide reliability for the grid, especially if the grid is constrained to accommodate more individual technologies. So it's a very nice way to combine multiple technology with single grid connection. And we are seeing more and more hybrids being developed around the world. So our goal in this task is to accelerate the development and deployment of hybrid wind power plants. But the challenge is this is a highly complex system which needs to be optimized, customized based on different locations. And our focus is mainly co-located utility scale hybrid power plant, mainly connected to the bulk power system. There are also smaller hybrid power plants behind the meter, in front of meter, connected in the distribution system, which we are also taking consideration in our another task 41. So here we are mainly looking at multi-megawatt scale in bulk grid systems. So we had a TEM in 2020 where we had around 74 participants and we had very nice discussions for 3 days, over 3 days. And then we had some ending questions, if I may say, and that should only hybrid power plant be developed in future. And there was a more disagreement to that, and I myself also see that there are different roles for different technologies, and this is a new technology or newer technology in the energy mix. We are going to see in coming days more and more. So, and is the market sufficiently available for HPP participation? And we don't see that happening, and that was clearly consensus there, that the 72% was agreeing to that. And then providing grid services as an essential capability from hybrid power plant, that's also a clear agreement. And then another point was that about to prioritize the experimental validation and developing test methods and standardization and moving towards that end, because this is not a low TRL as we speak level of technology, but rather you take the already developed mature technology and combine them in the best way. But then you need to have experimental validation and proof of concept that this works as a technology as a whole power plant. So we identified the market barriers that in order to accelerate the development of hybrid power plants, we need more demonstration of the economic values. And then there is also lack of data. There are lack of models for developing new hybrid power plants. And then there are also lack of tools in terms of optimization, control, and modeling of hybrid power plants. So those are the basis of our work packages. So
I'm sorry, are you supposed to share your slides?
I'm sorry, I didn't. Oh, I did not press the share button. I'm already in the slide 5. Oh, I don't want to repeat them, but
was a good talk anyway.
Okay, but then I'll keep. I'm sorry, my mistake. But I'll keep these statistics here just and repeat there that there was clear consensus that the market is not ready for HPP participation as it is today, and grid service is going to be the essential capability of hybrid, and then experimental validation is one of the priority for hybrid power plants that the task should support. And then we identified the basis for our work packages, like I said already, and I was here. Never mind. But so maximize the value of wind energy in systems, in energy systems, and in systems as in system of the hybrid power plant, and in market participation. And this involves all kinds of markets. We are in this task, we are predominantly working in electricity market, but we'll interact strongly with hydrogen TCP and also possibly with hydro TCP. But so then when we talk about markets, to start with, it is the bulk market or spot market as we see it, but balancing and ancillary service markets as well. Then accelerate the development and deployment of hybrid systems and determine the viability of the other induced products by wind-based hybrids. And there it is, hydrogen is one of the another induced product which we see more and more coming up, and hydrogen anode gas, like be it ammonia or methane or methanol. And then foster collaborative research also with other tasks and TCPs and other organizations around. And this is also what we are doing today. And this is a 4-year effort. And so that gives boiled down to 5 work packages, 5 rather active work package, and one on managing those other 5 work packages. Going into the details about those work packages, so it's about collection of research results, the first work package, so where we would collect, organize, and distribute the state of the art in hybrid power plants. And then how we do it is we want to develop a definition on hybrid power plant and different terminologies, because we see in literature there is hybrid power plant, hybrid power system, hybrid energy systems, microgrid, mini grid, islanded systems. There are many different kind of definitions, and all of them are true and correct in many different way. And so we rather try to have some consensus among the participants that what do we mean by hybrid power plant in coming days. And development of database of research results and algorithms for the industry and academia and research to get access to, expert elicitation and recommendation and best practices through different workshops as well. Milestone is to develop white papers and reports on the best practices and recommendations and roadmaps on that. Then the next work package is design a suite of reference hybrid power plants that can be used for some specific objectives. So we are talking about around 3 reference hybrid power plants. There we will decide on the number in the task. But then this is about combination of different storage technologies to hybridize the storage as well inside them. And then we can have wind-based hybrids for hydrogen as one of the use case there, or one of the reference case together with hydrogen TCP. And then dependence on forecasting, where what we talk here today as well, and I'll come into more details there later. And modeling needs and operational strategies and data needs. And those are the things to be considered in designing those reference hybrid plants. And there can be 3 distinct objectives. And what we started in the mind is one would be more on for the market participation, considering also the physical aspects of it. And that's what also Paul was referring to earlier. So this would include interaction with flow task as well, and market tasks or market operations. Then another one would be more electrical combining to provide grid services and the controls objectives, and how should a reference plant of that look like. And then so that's AC coupling, DC coupling, and whatnot. And then the third one can be about wind plus hydrogen to demonstrate the difference, like including the energy management, that when should be wind utilized for supplying to the grid, and when for generation of hydrogen. Yeah, and so we will have multiple workshops, and then based on those our discussions and studies, we'll write overview paper on with different reference hybrid power plants and a benchmark case. Next work package is about design and operational technology and algorithms, and this is probably one of the main work package which will have highest interaction with task 51. So here the building blocks are different control objectives and control technologies, including farm flow control and objective function and internal models, forecasting and optimizations or optimizers per se, and how to interact in different markets, and how to combine different technologies for minimum utilization or minimum reducing the requirement of land usage, for example, and things like that. So we'll also create a database of publicly available algorithms for hybrid power plant operation, and then evaluate the hardware and infrastructure needs for control methods. And we'll come into, we'll have to discuss details. This is not very clear, but I was thinking about putting a couple of slides on our ongoing activities, also from DTU, to show that why is it relevant, the forecast. So for example, we have developed some optimization models that we have wind plus storage storage hybrid that is using to bid in the Nordic market, Nordic electricity market, and that means spot market as well as the balancing market and or the regulating market in Nordic using the battery, and to see what is the value of forecast there. So in the maybe I can use the pointer. Yeah. So when we see that if so Oracle is the perfect forecast, and then we have a market forecast which is developed using LSTM machine learning database models, and then wind forecast is done using one of our forecast simulation tool at DTU called CoreLess. So what we look here is that if you do not have battery in your wind power plant, but you have a perfect forecast, then as compared to the imperfect forecast, you have opportunity to increase your revenue by 4%. But if you have a battery which you use for balancing, this is a bulk battery, big battery, so battery cost is not considered in this, but rather looking at the opportunity or the increasing the revenue, not profit per se. But only doing the balancing, then we see that when we have a perfect forecast, we can increase our revenue by 4.4%, and with imperfect forecast we have 1.3%. So 3% is eaten up by imperfect forecast. So this is the opportunity in increasing in the balancing market in Nordic system today. But when we did the whole optimization, so that includes spot market, balancing market optimization completely, then we see that there is around 10% of opportunity in order to increase the increase the revenue. And when we put the battery cost in, there was not a good business for this kind of case because battery is still expensive. But maybe there is a sweet spot when if the forecast can help us, and probably there are better forecasts around than what we have internally. So if we can increase this revenue here and the battery prices comes down a bit further, we can find a sweet spot where we can see more and more value for this kind of hybrids in coming days. So this is a very clear example where we can interact strongly with task 50. Yeah. Then the last work package, or no, not one, but last is the electrical design and control and market and grid services. And here again, the grid services and flexibility is where I think the task 51 can play a role, if especially the minute cast and short-term forecast, if we can use them in the controllability of the assets of the hybrid power plant, then that can be of high value. And so here also we will develop some open source model on control architecture, and we'll have some publications on grid service and grid codes, test and standardization. I'll skip this slide probably, and then the final slide is outreach and collaboration with TCPs, and that's what we are TCPs and tasks. That's what we are doing today, but they are not limited. But we will interact heavily with all these tasks here as we are doing today. And please feel free to contact me if you need more details, or Jen for that matter, and we'll be happy to provide you more information.
Thanks, Kaushik. Do we have any questions to this? Or is there a coffee break looming? But we also can, no, Grüner.
Yeah, just a very quick one, Kaushik, because I'm kind of a bit surprised about the study that you made, that the market is not ready for the hybrid. That's kind of strange. What do you think? Why is this? I mean, I remember like in 2003, 4, 5. Japan already started kind of making hybrid systems because the balancing was so difficult. So they required that there was storage attached to wind. And why do you think are we not further in this? Is it because we require higher penetration levels and it's only starting now, or that we have all committed, I mean, all the countries and have been committing to 80, 90, 100% renewables, that we are kind of, this is more a topic now, because I think it's very important. It's the way to a CO2-free energy system. But I was just wondering if you could.
Thanks for that comment, Corina. But to start with, this is not from the study, but from the survey from all the industry partners, industry and academia. So there was a clear consensus that they see there is still far way to go. And then based on our studies, what we have done, I can answer a bit more to your question probably. That what we see is that if you also look now, Wind Europe has very nice infographics and also a tool where you can see why each hybrid power plant is being developed. So all of them are being for very special cases, like you mentioned in Japan. And then there are grid congestions or specific grid requirements or very specific power purchase agreements coming up in India, like peak power support or around the clock support. So always those special case hybrids are coming up, but not bulk participation like what we see for wind, that you just go and connect a hybrid power plant. And that one of the major reason is still battery is expensive technology. We see very sharply going down. One reason. Second reason is the electricity prices. If we just look at electricity market, not going into hydrogen yet, the prices in many parts of the world is not that fluctuating yet. We see it happening more and more in Denmark this year, and also balancing prices going very up in Belgium and other places last year and this year as well. So that's happening, but in maybe 5 years we can see that it's happening much more, that those energy management, like shifting bulk power to a high wind, storing the energy into battery and supplying it during the low wind period becomes profitable. But with the battery cost today, it's still not profitable as I see. And we are waiting for those special PPAs or special case auctions of hybrid.
Okay, thanks very much. That was interesting.
Good. I don't see any more questions. So then we'll have 5 minutes coffee break because we're not only a little bit behind the schedule, but we have luckily enough space at the end to be able to finish in time. So yes, please be back in 5 minutes, and then we'll take the second half of the of this meeting. So it's 1550 UTC, 1650 in Copenhagen and Switzerland. And time for the second larger session of this workshop, where we are having the talks from the external participants. So external to the IEA Wind TCP. The first one is has been actually a frequent guest at our meetings, Jan Remund from the IEA PVPS Task 16. And he will tell us a bit about solar forecasting and the general solar resource arena. Please.
Okay, welcome everybody. I couldn't find the unmuting button. Yes, thank you, Gregor, for the invitation. I'm Jan Remund. I'm the task manager of IEA PVPS Task 16, as it is called now, and I'm working at Meteotest in Bern in Switzerland. I will give you a short overview of the state of the task. It's quite a big task, at least for a PVPS. We are about 19 countries, 50 organizations, and about 90 experts, including Chester Browell, which is the liaison officer and somehow between the tasks. And as Gregor said, I have been invited already once or twice to the meetings and to special working groups, which we appreciate very much. The PVPS has also links to solar paces, to the solar chemistry, and to SHC. It's solar paces task number 5, and with SHC we have just a standard calibration. We have quite a good coverage from the world. Actually, South America is missing. We had Chile on board, but they had a withdrawal from our task. Currently, we are in the second phase. The numbers are not changing in PVPS. That's why their numbers are so low, much lower than in SHC or Wind Task. Our task will end in 1.5 years. We are just in the middle of it. The main outcome of our 3 years periods are the Solar Resource Handbook, which concludes the work, most of our work. I will show you the results just in the next slide. Currently, we are doing benchmarks for solar resource data forecasts, and we are planning already a next update of our Solar Resource Handbook. It is divided in subtasks as many other tasks in wind and other TCPs. Subtask 1 is about measurements and models, led by Manojit Singh Gupta from NREL and Stefan Wilbert from DLR. Here we are looking at ground-based methods and models, at gap filling, and defining also the back processes for measurements. Here is the first major link to task 51. We are also dealing with special benchmarking frameworks. Subtask 2 is about enhanced data and bankable products, led by Philippe Blanc from Partidário. It's about quality, format, long-term variability, products, PV at urban scales, data and models for bifacial modules, and also solar cadastres. Subtask 2, this is the subtask dealing with forecast. This is led by Elke Lorenz from Fraunhofer ISE. It's about regional forecasts, probabilistic forecasts, all sky images, and firm PV generation. And also here the red marked parts have also strong links to the task 51. Subtask 4 is about dissemination. This is led by myself. The major outcome is our solar resource handbook, but of course we have also workshops, webinars, and also our online code archive. So our major outcome is this handbook here. It has 2 versions. One is NREL version and one PVPS, but actually the text is the same and the images and contents. It describes all major questions. It's a mixture of basic knowledge, state of the art, and also the scientific results. It shows also how, the practitioners which data they can use in which part of their project. This is focused or concluded in this table here. Here we give an example, or we show what kind of data is used depending on the system size and the phase. As you know, PV can be very small and very large. Of course, you need different meteorological and climate data for this. And of course, also bigger installations have more phases than just small building top PV installations. Coming to the solar forecast and giving two examples on which topics we are working on. Here is our description on which topic is the best for depending on scale, on spatial scale, and on temporal scale. Beginning with time series models for seconds, cloud it is the all sky images for minutes and kilometers, and then cloud motion based on satellites for several hours and kilometers, and then going to the numerical weather prediction models. We are making benchmarks on all sky images, and I will show you also some work we are calling firm PV power. I will declare what it is, but it is mainly to deliver by PV 24/7 for the whole world and on all regions. Just the result of our benchmark for one of the 5 cameras which have been put together in Almeria in southern Spain. That's the first time where such cameras are put together and could be benchmarked, because results depend very much on the climate and also the season. There is good results. So for all cloud classes, better results than persistence resulted. And especially for the cloud classes with high cloud influence, at the right side, you see the definition of the cloud situation. There, the main gains are seen. And additionally, what is not visible here, it can detect the ramp rates very well. So this is an additional pro of this type of forecasting. But for sure, at the moment, it's still a niche in our technology. It is mostly used together with PV diesel hybrid installations, and also for CSP plants, but for general plants, it is not yet the case. Another topic is this firm PV power, where we want to deliver 24/7 by PV, of course, not alone, but together with wind, together with hydro, together with other parts, and of course with storage. We defined here some kinds of 3 phases of the energy transition. At the beginning, it was every kilowatt hours did count. It was important to build more and more. In the current situation, it's about the production. The load is the same, but mostly it is lower than the load. Curtailment is seen, especially in wind. In PV, not that much, but more to grid congestions, not due to that the load is higher. But we will come to the OR partly already there, that the production is much higher than the load. And then, of course, the capacity and timing is counting, not every kilowatt hours, and curtailment will be standard. And there will be a mixture of hour sizing and storage, and we are calculating in this work where the optimal shares are. You see this in this optimizing graph here. At the first point is PV alone, no curtailment at all. And to the right, the D would be a lot of massive curtailment overbuilding, and there will be some sweet spots where and these spots are then calculated, and optimally they are lower as this line D, which are the today's costs of the system. This is all is based on the assumption that the storage costs will be higher than the production costs, which is for sure the case for PV, but also for wind. And in the US case, where this has been calculated by Clean Power Research, they included also wind, and a mixture of all will help much, of course. We are calculating this at the moment for Switzerland, which is quite difficult because of the assets we have. Wind power would help a lot, but there are certain limits to that. We can only include a low number of this. And also here you see the same, but we get to these low points like 6 to 9 to 10 cents per kilowatt hours, which would be quite reasonable. And you would have to overbuild PV in this example, preliminary example, about 30 to 40%. Of course, storage is needed, but if you would take every kilowatt hours from PV, it would count too much. So our work is concluded in this solar resource handbook. I'm inviting everybody to have a look on this. We are ongoing our work and which aims to define and lower uncertainties. The benchmarks with all scamages are ongoing, and as well also this work as on firm PV power. We will start soon the discussion about our third phase, which will start next year. It's a good point now. We have now also this new work plan of task 51, which is important also for us to define our work plan then this year and next year. Thank you very much. That's all from my side at the moment.
Thanks a lot, Jan.
You're welcome.
Always a pleasure to see what you're up to and how much it actually links to what we're doing. Do I see any questions? I don't quite know. In how far, maybe I can have one. In how far is dust and aerosol content also a problem that you might or might not be able to get from sky cameras or from satellites?
Aerosol is a major topic. It's mostly based on satellite measurements, but they don't see it if you have clouds. And soiling, as we call the dust which goes on the modules, is also another major point which is modeled and quite a lot, especially by DLR in Plataforma Solar de Almería. Here we have also a collaboration with the task 13, which are working on this more on the technical side, but both are important topics and ongoing work, yes.
What is task 13 usually looking at?
At the quality control of PV, how they,
okay.
Yeah, that's the biggest task in PVPS.
Yes, George?
Yeah, I would like to ask, the next task, you said that you are starting discussions. Could you give us some hints about the main directions you see as perspectives of the ongoing task? Why I'm asking this, because for example, in our task, we have this, let's say, quite innovative concept or matricial organization with the work streams. And if you take the work streams themselves, I mean, almost each one of them or most of them could be also applicable to photovoltaic. I mean, they are not necessarily ideas which are specific to wind. And the work we are doing behind anyway are not specific to wind, are on these streams, on these ideas. Most of us are doing, we work on these ideas, both for wind and solar. So I would like to know if in the future, the next phase, if you see, if you have any idea of the main directions and, you know, you just have this in mind to see how we could better collaborate. So I'm George Kalinais from Min Paritech, actually.
Yeah, okay. It is, we had the first discussion last September about how it is going on, but it's really vague. So we are really interested in having such inputs as you had, because this new task definition will really start. Of course, we want to go on. One topic is, for example, offshore PV. which is also coming, like offshore wind. Albedo data is very important, especially for this bifacial technique, which is modeled, used more and more at the moment. And then also some long-term climate outlooks, including volcano modeling, which can be important for PV production. But this kind of thinking you just mentioned, we didn't take into consideration. So we are really interested in having also more information about this. So if you could send me some links or some ideas, then it's a good point to do this at the moment. End of March, we'll have our next task meeting. And then there's the point to start this discussion.
I think everything will be present tomorrow, actually.
Okay.
Introduction of the working stream. So.
Okay, we'll have. I can't be all the time there, but I try to have a look at this. Yes, thank you.
Thank you.
Good. Then on the program, we had the hydro annex. Thanks, Jan. And unfortunately, they couldn't find the right speaker in their annex. So there we actually gaining 15 minutes, which I obviously knew when I let the discussion run. And that means we're only 15 minutes late with the talk of Paulo Partidário from the hydrogen TCP.
Hi all. Thank you very much for having us here. So my goal today is to talk to you about the hydrogen TCP, and in particular to give you insights about the specific task that will enable to have an interface for collaboration with the task 51 of Wind TCP. I will now having I'll share my screen. Right. Okay. So yeah, my name is Paulo Partidário. I'm the Portuguese representative in the executive committee, and I'm also about preparing the new task on offshore hydrogen production. We have in this starting by just giving you an overview of the hydrogen TCP. There are the executive committee has 33 members based on the countries, sponsors, and European Commission, and yeah, and we all also UNIDO is involved, and we are in different activities. This is a TCP that has a track that tracks back to 1977 from the portfolio, the project portfolio. This TCP has already performed different tasks. There were annexes before, as you know. It's a new naming, and there was in fact I think from the beginning till 2017 there were 36 tasks that have been completed. I would say that the mission is very much focused on covering the hydrogen production, efficiencies and effectiveness on the strategies of production, and also the transportation, storage, and end use of hydrogen. So there's not much back experience on foresight, though foresight and also strategic planning are key issues for technology, and the hydrogen TCP should not be an example that should be far from that. So I believe that this new task can be an option and to discuss foresight and in forecasting in particular, because in fact we need renewable energy to support the generation and the production of energy of hydrogen as a vector. And so in that sense, I'll provide some insights. I would like just to mention from the mission canvas, I would probably just emphasize the mission achievement and impact factors, where we try to, in fact, to have a future base for a clean, renewable and clean sustainable energy supply based on hydrogen that should play a key role in all sectors of the economy, in particular those sectors that are more difficult to have CO2 abatements. So in that sense, so it's not a real competition with hydrogen, as we found out also from national energy analysis. There are in fact some value chains that very much depend on the context. So it doesn't mean that we should always discuss hydrogen from the point of view of supplying electricity. That depends, of course, on the energy balance on each energy system. So that said, and based on what is also our understanding, that should be the increased awareness of on hydrogen technologies should be also improved. So that's also part of our portfolio, and also performing R&D projects that also will enable us to improve the different parts of our mission. The portfolio, the current status is this one. In fact, we moved since 2017. There was a big contraction of activities. We are in fact making an effort to renew the task portfolio. There are a significant number of tasks that are being created. One of them is the offshore hydrogen production. I'm referring here to value chains, because in fact we are trying to optimize what could be the investments on offshore hydrogen production, so that we can in fact specialize different segments in the market. Based on all that, and I will give more insights in the next slide. But before that, let me just tell you about the 6 different tasks that are in fact now running. 3 of them are already having some more experience. It's about hydrogen safety, the hydrogen that addresses power to hydrogen and hydrogen to X. And this is also there's some overlap with this new task that is being envisaged with the offshore approach. But nevertheless, it is about new experiences, and I'll talk about that in the next slide. It is also about the new fuels for transportation. In particular, task 39 readdresses the maritime transportation with hydrogen. But there's also a very interesting task that, though it is not about forecasting, it's about energy system modeling, because it is very much about the energy system itself, but also the life cycle approach, and it is very much about data quality assurance and quality and control. Because it's something that is, from the best practice point of view, it's also something that is common to foresight and the quality of data in the foresight exercises. Finally, there's another task that is also key, and as I see that also there are Portuguese colleagues from REN, the Portuguese TSO. I believe they will know already that Portugal will also be addressing this task with our Portuguese TSO. So based on this, I could say in brief that there's no experience, or there was not identified till now any interface with the forecasting issues, though it is in fact very important because the hydrogen production depends on the weather, depends on the primary renewable energy, like we are having today, a lot of lack of rain. We also, this is the case of the Portuguese energy mix, for instance. But when every natural resource is lacking, there's then an imbalance, and it's in fact important because it impacts the business models. It impacts like you have as a main goal in this new task on wind TCP. It is about managing bids, it's managing auctions, everything that can in fact impact the business model in the interface with the markets and the trading. It's important to anticipate. So in the case of this task on offshore hydrogen production, what we need in fact is we should in fact address as well this variability of weather conditions. So it's important also to be involved not just as a user of your own task, that's our proposal, and I'll come back to that in the next slide, but also as not just from the downstream stage of our value chain, but also upstream. We need in fact to share with you, and I believe we have to talk so that it will be possible within the IEA framework, general framework, to have a collaboration with you. This specific task, just to give you some flavor of what could be the next stage, because in fact we have already some interested parties. There's more countries coming in, but in fact what we see, we envisage that in fact there will be within the IEA collaborations with different TCPs, and also outside IEA like IRENA and the Clean Energy Ministerial. This is the general portfolio of the collaborations inside the IEA and also beyond that. And finally, within this general value chain, where somehow it could be represented, this is a diagram that is available in the webpage from the TCP. And you could see that there's a main representation of the whole system, but in fact, we mainly focus on the hydrogen production and the interim stages of the life cycle, and then the end use. And finally, just to somehow to address key issues for further discussion, I'll be available for that. So within the TCP framework, in fact, we have to deal, and each TCP has its own specificities, strategies, and uncertainties. We identify, in fact, in the case, for instance, of the offshore hydrogen production, that it really needs, in fact, to share these uncertainties that task 51 of wind TCP addresses as well. So that, yeah, so we have a common issue. And from other perspectives, I believe that it would be possible to contribute to this Wind Task 51 as having an end user approach. And finally, from more upstream, this the forecasting activity could be very interesting for us. So this kind of approach, we should discuss it in more detail. Thank you.
Thank you very much. I found that really interesting, and especially this task 41 is one that directly piqued my interest about data and modeling, because what I think is that we're especially needing some input for the modeling about the technical limitations, but also just simply sub-models that we then can use for our own optimizations. And one of the things that I wanted to ask is, I'm hearing that electrolyzers should be getting as many full load hours as possible, but is that only a economic problem, or is there also technological limitations in ramp rates or anything or any similar things?
The electrolyzers, depending a bit on the type, some are more easier to have a continuous regime than others. But the issue is not generally limited to the number of hours that there's enough energy to be on work. So if we have a good regime of primary energy generation, renewable, then we can optimize and have a good productivity on the electrolyzer, and that will be good for the business. So it's a question of having more, and that's one of the reasons why we also feel attracted by the offshore approach, because then we have more availability of renewable power coming from the ocean, coming from the wind that is in the ocean, so it will be more intense, more stable. So in that sense, also this uncertainty and the variability could reduce.
Okay, so what we've heard before from the airborne wind energy community with 60 to 80% capacity factor, that might actually be a very good match.
Yeah.
Thanks. Corinna?
Welcome.
Yeah, thanks, Paulo. That was very interesting. And I think it's a little bit like with the hybrid task. There are definitely a number of areas where we overlap strongly. And I see also the hydrogen kind of as part of our uncertainty propagation, because the hydrogen generation from the uncertain part of the wind that may not go into the grid, or, you know, it's not only the storage, but storing a lot, but also leveling out, being able to level out uncertainties that may be something that we could work on together. And then I can see that maybe it will be an interesting task to make such an experiment or game where we look into how can these technologies be brought together and handled. So that's where I see quite some overlap, and where we should work together in the next couple of years.
Great. If I may comment, I trying to structure this new task in a way that there'll be the chance to make hybrids not just with the wind, but also depending on the maturity level that the technology might have on a certain moment, that we could also add ocean energy. We could add if there'll be some technicalities on the sun ray angles. We can also add, I wonder if you are aware of technology that is, at least in Portugal, in a highest level of maturity on photoelectrolysis. So it is possible to introduce that if the sun ray angles are controllable, because nowadays it is very, very uncertain. It's very, very variable. Yeah. So the hills are very low. But in fact, there are some savings from the space, the room necessary to install. At least from that point of view, it's already something that is very interesting. But also we have a very big challenge that is about the electrolyzer. We need to improve the stacks. Otherwise, it is not possible. Yeah.
Yeah. So, but I don't know whether we can look upon this like the storage. I mean, it certainly should also be looked upon what are the uncertainties and what are the generation in a large scale system or a smaller scale system? Maybe, I don't know whether you have a comment on that. I think the hydrogen generation would be more on a smaller scale, on a local scale, to balance and maybe cascade certain generations, so that there is we avoid the curtailments in areas where you lack kind of transmission capacity.
Let me comment on that on this basis. At least from that's one reason why we give a lot of attention to the business models. From our national experience, our storage effect coming from hydrogen will come firstly at the level of the molecule applied to the gas network. I believe that this model of offshore production will be more based on the molecule than on the electron. And then it will be also possible from this point of view, the value chains also to develop based on shipping. So there'll be some simplicities within the layouts. Also, we could somehow, if the technology on offshore grid will develop and the cost will go down, then we also can use the electron. But I believe that will be more interesting to start with the molecule and address all the strategies based on that.
Okay.
Yeah.
Thanks.
Welcome.
Any more questions? If that isn't the case, then thank you, Paulo.
Welcome.
And the next speaker is Elina Mäki from the Bioenergy TCP, and I already had sent some questions beforehand, which I'm really interested in seeing whether there's actually any forecasting angle or whether there's other ways of collaboration.
Yes, so hi to all, and thanks a lot for inviting Gregor. Can you see it in the full screen?
You're showing the wrong screen. We see your own screen. Yes, if you switch that.
Is it now good?
No. Yeah. Now it's good.
Okay, great. So I'm Elina Mäki, and I work at VTT Technical Research Center of Finland as a senior scientist. I work there mainly with different renewable energy concepts, their deployment, development, and analysis. Also a lot with flexibility and grid integration aspects. And I'm also leading IEA Bioenergy Task 44, which is called Flexible Bioenergy and System Integration. Also, my Task 44 colleague Kristian is online from DBFZ, Germany. And she's actually also a co-lead in Task 40, which is for deployment of bio-based value chains. So she's also to listen and maybe provide a different angle for the topic as well. Task 44 is actually not doing forecasting, but after talking with Gregor, it's a good question if we actually should be doing more forecasting, because feedstock flexibility is an important part of bioenergy flexibility, and that relates to for example, quality and availability of different feedstocks. Where we are focusing on is to create a clearer picture of flexible bioenergy, what it is and what kind of services it could provide for the entire energy system. We are focusing on technical aspects, policies, market designs, and value of flexibility, for example. And well, there is a lot to tell about flexible bioenergy, but today I will try to focus on certain aspects, provide you some background and hopefully some food for thought for future collaboration. And I can already see that the system integration aspect provides many interfaces to forecasting issues. First, a little bit about IEA Bioenergy TCP, because I don't know how familiar you are with that. We have 25 member countries and European Commission as a member as well. The work is conducted in 11 different tasks. And in addition, we have different intertask projects which are participated by different tasks. You can see here that task 44 is marked to the 2 outer cycles. So meaning that we have the system perspective and we are working in the different energy sectors, electricity, heat, gas, fuels. Task 44 started its operation in 2019. So we are a pretty new task. And the tasks in IEA Bioenergy TCP are working in 3 years periods. So we have now done 1 period and started the new one in the beginning of this year. We are actually having the kickoff meeting of the task in March. So this is a perfect time actually to start talk about future collaboration with other TCPs. In this triennium, we already foresee collaboration with IEA ETSAP and IEA Hydrogen in our activities and have already talked with them about these. Then to start with, a little bit about the expectations towards bioenergy according to IEA's net zero emissions roadmap. So in their scenario, they see that the amount of or the use of modern bioenergy will be approximately 100 exajoules in 2050, and that means that modern bioenergy will supply almost 20% of the total energy supply. And the bioenergy will be used in different forms: gaseous, liquid, solid, and in the all relevant energy sectors, meaning heat, electricity, transport, and industry. And IEA evaluates that the global demand is well below the assessed sustainable potential. IEA also acknowledges that the need for flexibility in the electricity sector will be fourfold by 2050 compared to today. And they estimate or foresee that this flexibility is mainly provided by hydro, batteries, and demand response. Also, flexible bioenergy is explicitly mentioned in the roadmap, but it's not described what kind of flexibility bioenergy could provide. And it's also not mentioned in this figure in the roadmap. So bioenergy can actually be increasingly used to offer low carbon flexibility and different services for the power system. Here you can see different categories of flexibility in the power system, and actually we can find bioenergy in quite many places. It can of course provide flexible generation, but also flexible demand, help in sector coupling, and provide energy storage options in different time scales. When we talk about flexible bioenergy, we usually first think about flexible biomass boilers, for example, in CHP production. And there, the flexibility comes from fast cold startups, fast speed load changes, and from a wide operational range, especially from low minimum loads. These are the technical aspects, but actually bioenergy has some unique features which support the provision of different flexible services. Bioenergy can be used for example, to cogeneration with flexible output ratios according to electricity prices. So we can produce different combinations of heat, power, fuels, and also other products. Bioenergy is the only chemical energy source in a non-fossil energy system, and it's also naturally easily storable in different forms. And then if we think about what kind of flexibility options bioenergy can provide, at Task 44, we created this kind of map of potential pathways which start from different feedstocks and end up to different applications. And especially with different energy carriers, we can provide both spatial and temporal flexibility. And this temporal flexibility we can further divide to different time scales. What's notable in this figure is that we have a lot of options that are already technically and economically feasible, and they are in use. But these technologies are not giving to the system the full potential of their flexibility. So one example is CHP plant, which nowadays is typically aiming towards high full load hours, though it could provide flexibility to the system. Also, we can see that there is a lot of hydrogen and CO2 marked in the figure. And we think that the upcoming hydrogen strategies, which are now in preparation or already in use in several countries, will open many synergies with bioenergy. And that's something we are focusing a lot in this new triennium. And in Task 44, we learned when we did this technology screening that we have so many different options to provide flexibility from bioenergy that it's really hard to define what flexible bioenergy actually is. And this is the definition we ended up at this point, but it's organic and can change. So we have defined flexible bioenergy as a bioenergy system that can provide multiple services and benefits to the energy system under varying operating conditions and or loads. And here are some examples. And actually the first one relates to providing grid stability for a power system where the amount of variable wind and solar energy increases. And well, typically when we talk about flexible bioenergy, we connect it to power system, but actually we think that we should go beyond short and midterm flexibility provision and beyond services for the power grid. And this is actually enabled by the long bioenergy value chains, which go from feedstock to application. We can provide long-term flexibility through the storability of bioenergy, and we can provide also flexibility in other sectors than electricity, as bioenergy can be used to produce multiple products. But valorizing these different system services and flexibility options require that we have a complete perspective to energy system and the supply chains. And what makes this a bit challenging is that the flexibility provision and demand for flexibility is very case specific. So different countries and even areas have different energy systems, different market mechanisms, different feedstock availabilities, and even different climate strategies. So this is always really case specific. And what we are actually doing at Task 44 is to provide best practice examples of flexible bioenergy so that we can see how the environment affects the flexible provision, and also to see if we can learn from area to area or from country to country something. And well, then to sum up a little bit our perspective on flexible bioenergy in the energy system, first of all, we need sustainable resources and modern bioenergy. And to this, the feedstock flexibility links a lot. So we have to be able to use increasingly waste and residue feedstock as an example. Then we will have increasing amounts of variable generation in the power system, and it requires a flexible counterpart. And one option is flexible bioenergy, and it can provide the operational flexibility. Then we can have, or we'll have storable biofuels. And this relates also to product flexibility. So we can produce different products from our resources. And these storable biofuels can be used in those sectors that are hard to electrify. And as the next point, we have hydrogen. So there is a lot of talks nowadays about hydrogen. And the interesting question is how it relates to bioenergy. First of all, we can produce hydrogen from bioenergy or biomass, but that's maybe a niche application. And more interesting is how hydrogen can be used in bio-based processes. And this hydrogen, of course, couples bioenergy really strongly to variable electricity production. And as the last point in this figure, I have also CO2. So we can capture CO2 from bio-based processes and either store it or utilize it. And this figure shows the utilization pathway. So we can combine the CO2, biogenic CO2 with hydrogen and produce different products. So this is our overall view of flexible bioenergy in the energy system. Then a little bit more about task 44. So as I told, our aim is to provide a clear figure how flexible bioenergy can contribute to energy system decarbonization, where we are now, what kind of options we have in the future. And I show you here our work package structure for the new triennium. So as the first one, we have flexible bioenergy concepts, and here we will keep updating our technical map of the pathways, how bioenergy can provide flexibility, and we will also provide best practice examples. The second work package is flexible bioenergy integration in energy system. So we want to learn more how bioenergy can help to integrate the variable generation in the system. And here we will also look in the flexible bioenergy and hydrogen in energy system modeling. And I can see that the potential collaboration highly links to this second work package. As a third work package, we have acceleration of flexible bioenergy concepts implementation. And here the key question is, what is needed to create value for flexible bioenergy? Then additionally, we have some in-the-task projects. One is synergies of green hydrogen and bio-based value chains deployment. Here we will collaborate at least with hydrogen TCP. And the other in-the-task project is PECUS, where we will focus on the synergies and trade-offs between flexibility and CO2 capture and utilization. Then something that might be interesting for you to study a bit more, especially this first report. So all these three papers are produced in our task in the past triennium. The first one is technologies for flexible bioenergy. And here in this report, we introduce different flexible bioenergy technologies. And what might be especially interesting for you is that there is a long list of annexes where we have collected technical and cost data for these flexible bioenergy technologies. For example, ramp rates or minimum loads of different technologies. And then the second report is about the implementation of flexible bioenergy technologies in different countries. And the third paper is kind of a summary paper from our task and what are the next steps to implement flexible bioenergy. And well, if you want to find out more, we have an active LinkedIn group, and then all these reports are available at our website. So that's all today. Hopefully you could get some understanding what we are doing.
Thank you very much. Yeah, as I already mentioned in those mails that we exchanged, so far I had been seeing bioenergy as a problem mostly for the seasonal forecast, because it can be stored, but there might be some percentage of the biomass supply that has maybe a good harvest or not so good harvest at a particular point in time. Is that maybe something I've seen that there is a task 43 biomass supply? Is that something they do, or is that something you do?
That might be something they do. I'm not sure. That's actually the task in IEA Bioenergy that I'm the least familiar with, but I can be in contact and we can also brainstorm with them. And yeah, as I told after talking with you, I started to think about this, and it might be also something we should be doing. This feedstock flexibility is something we have acknowledged to be an important part of bioenergy flexibility, but that's something we haven't touched so much yet in our task. Kristian, do you want to add something?
Yeah, thank you, Elina, and thank you, Gregor, for your question. Yes, and indeed, actually, Elina and myself, we were discussing this beforehand, before the meeting today. And we were also thinking that not only our task, but also other tasks in bioenergy TCP would be relevant for this discussion. So I also would agree to Gregor, what you discovered, that task 43 for mobilization would be something interesting. And we also have been thinking maybe also on task 37, which is on biogas. Because this is also something else that is relevant, because you were saying about seasonal, and I would like to say it's really about the storability, because the seasonality that you are touching upon is mainly like relevant for agricultural harvesting. But these are not the main feedstocks we want to see in future. So we want to be more in the residues areas to be more sustainable. And so the question is, how are these residues are structured, and are they more wet or dry, and can they be stored better because they're dry and you have troubles to store them because they're wet? Or what I was talking about with biogas, there you're not only having the feedstock flexibility, but also the intermediate. So when do you produce your gas, and how much can you store of the gas? So definitely this is something that we would need to explore further, how this could link to the activities that you are doing. If this is maybe that you were referring to.
Yes, exactly. It sounds like we should have maybe a small brainstorm meeting with a few of the people that then raise their hands later on. And if you want to be part of that from task 51, let me know, and then I'll try to loop you in for that one. Thanks a lot.
Yeah, that would be excellent. Can I just
Sure.
a question back to you from your introduction? I had just was going and sneak through the work packages that you're having, and at the moment you're suggesting the main link to MVP1 to seasonal forecasting, but you were just mentioning. what I just saw was maybe also work package 3, but of course there were only headlines, so I'm not sure what is quite behind this. Just for you maybe to take a note that maybe we can talk further about work package 3, because there was something written like extreme power system events or value of forecasting. So maybe this is something where we could also find some links, because we're looking into the value of flexibility. So maybe there's something else we could cooperate on, but this is just from the headlines without knowing what you're really up to in this work package 3 and also 1 then in the end. Thank you.
Yes,
Maybe just a quick note, sorry, Elina, as work package leader 3 for work package 3, definitely, I do not see the bioenergy only in the seasonal. I definitely also see it in the shorter terms and the value, and also like with the hybrid plants, bioenergy can be part of a hybrid plant, and there is some uncertainty that we can work with. So I see this also in the uncertainty propagation, not only in the value. So definitely we should have a brainstorming on how we can collaborate on that, and how we can integrate you into our work.
Okay, great. But as far as we understood, you're settling at the moment. So we are settling with our new trinium, and you're settling with your new migration to the new number. So
correct.
Yes. Good.
So I will be in touch with you anyway.
Actually, if I can complement, because well, in the frame of work package 3, actually it's a question of value of the renewables, etc. But from what we see in general, this is a question that's posed by every technology. I mean, we are contacted, for example, by industrials who develop PV plants, and they ask, okay, should we integrate, for example, electrochemical storage or electrolyzers, etc. And if we do, how do valorize this? So we are moving to actually to aggregators, to actors who, in reality, they have multiple sources. And they valorize it mainly in the market with common ways. So it's a kind of transversal problematic, actually. And I think there are many things to learn from each other, because, you know, given that maybe bioenergy is more predictable and in the long term and can be used as a hedging of uncertainties, etc., we can have in the long term, we can find in the models we develop and when we simulate how we can optimize, for example, flexibility in multiple markets, etc. If we could have models that represent also this source of energy, we could, you know, have a good interaction and have some, yeah. So. Because nowadays, well, the question is not posed for a single technology. I mean, how to valorize, for example, biomass in the markets, or wind, or storage, or hydrogen, etc. It's we are in the case where
there's also IEA Task 26 for economics, which is looking into this. But I think we need to close this discussion and go to the last task, because despite what I thought, how we were in time, we seem to actually be getting over the limit a little bit. And so it's my pleasure to get Roberta Boscolo on stage. Actually, you're on stage already.
Yeah. In the interest of time, I already shared my presentation.
Please. So please take it away.
Thank you very much, Gregor, and thanks everybody for having me here today. So I think this is really an important step that brings together the IEA and the WMO closer to address the fundamental issues related to the understanding and predicting the wind and the renewable system, and therefore enabling the clean energy industry to develop and support the energy transition that is what is needed now for our sustainable development. So before I start my presentation, I would like to thank also a member of my team, Hamid Bastani, who helped me to put together this presentation. So the purpose of my talk today is to really show what WMO is doing, or better, what has started to do recently in order to support the clean energy transition and security. It is clear that while in the past, the meteorology was really important for the energy industry, for predicting demand and building resilience for the infrastructure or operation and maintenance, with this massive rollout of renewable energy as is expected, meteorology will play a key role in the energy generation. And all this system has to consider the element of climate change, of course, which means that what happened in the past is most likely different or what happened in the future. So, in this sense, WMO has recognized the importance of the Earth system observation, data analysis, and products has for the energy sector, and has established a study group to specifically address the needs of this sector. So it is extremely important that we connect with group like yours and the other task group that I heard today to understand what is the requirements from the users, from your community. So to be better in a good place to provide a better observation, better data analysis, and add value to our knowledge. So my presentation will touch on a bit of the history of the study group and also how we operate and the main activities that we have. And so at the end, I want to finish off with some concrete action and what is going to be, what should be, I think, our collaboration in the future. So I'm assuming that everybody here is familiar with the World Meteorological Organization and what the WMO does. Anyway, WMO is a United Nations specialized agency for weather, water, and climate, and it was established about 70 years ago, and the headquarters is in Geneva. So the members of WMO are countries and that have an operational meteorological services that support national needs. And the countries have a representative that participate to our Congress. So WMO Congress in 2019 approved a major reform in order to engage and coordinate with the experts worldwide in these fields. It established 3 major bodies of commissions to advise on 3 major areas of WMO operations. And this is infrastructure, which includes observation, data exchange, products like forecasts, predictions. Then Research and Innovation Board, which it covers the part of research and innovation, and the services, which is the adding value to these products for specific sector, which is water management, disaster risk reduction, aviation, agriculture, food security. In this commission that has historical services, like I mentioned before, they constitute the standing committee. And when I talk historical services, I mean services that WMO has always, since the inception, provided and developed, and it's aviation, agriculture, climate services, hydrological services, marine services, and disaster risk reduction. But in this new organization, now they introduce 3 new services, say, in terms of study groups, so exploratory services, and is health, energy, and urban services. So this is the actual composition of the study group. These are the members. We have about 18 members that were selected among those nominated by the countries. And the nomination process is rather complex, as it is always in the intergovernmental organization. But we really try to ensure a geographical balance, gender balance, that you can see is not extremely great actually for this study group. And also the cross-sector balance in terms of operational meteorology, NGOs, academia, regional and national center of excellence. Those members that were nominated last year will serve for 4 years. And we are now thinking to expand the group by including the role of observers, which means that this role would be to facilitate interaction with the key partners and key institutions like IEA, IEA, the World Energy Council, and etc. So the study group builds on the work already initiated with an initiative called the Global Framework for Climate Services, which was an initiative which was a UN interagency initiative which was launched in 2009 through the World Climate Conference. And such initiatives started with promoting the development and implementation of climate services for 4 sectors, which was water, health, food security, and disaster risk reduction. But in 2015, energy was added as the 5th sector. So WMO put together a group of experts to develop guidelines on how to develop these services for the energy sector. And this is a publication which was launched in 2016 and is also available in WMO electronic library. So based on this initial work, the study group member has their first to develop a work plan for the next 4 years. And these are the 7 priority areas of the work. Basically, the first, the dark green is what we are actually doing now, and I will explain later in my presentation. And then we have the light green that are ongoing, but with a less focus. And then the last 3 brown color are we are going to address it later. So of course, due to COVID, the group has not been able to meet in person, and we really hope to do it in 2022, as you also are planning to meet in person soon. But we had 4 virtual meetings so far, starting in December 2020. And all this information also, we have a web page in WMO for if you are interested to see what we are doing. So this is actually an activity that I want to mention, but it is not actually an activity of the study group, but it is something related. So WMO publish every year the status of the state of the climate services. The first 3 editions were on agriculture and food security, risk information and early warning system, and last year it was water. And I want to announce that this year it will be on energy, and it will be also launched at COP27. We are now putting together the this publication, and probably some of you will also be contacted to either provide case studies or provide some contribution for this publication. Okay, so this one is a publication that we are just now finalizing. It builds also, as I said, on the previous publication of the Global Framework for Climate Services that we published in 2016, but it expands more to include weather services. So it's not just climate services, but it's all weather, climate and water services for the energy sector. And also this publication is going to be aligned with the Paris Agreement target, and is tried to have a way to understand where are the gaps in terms of data, stakeholders engagement, institution capacity, etc., that will guide also the work of the study group. As we have an outline of 8 chapters here, and you can see that we are really looking at the full value chain of these services. And the publication proposed actually a framework for conceptualizing the weather and climate services value chain, building on the framework previously developed in WMO for the weather services. And this framework combines elements of co-production and approaches, which means it is really important when we are talking about what kind of products energy sector needs from meteorology, is the starting point is to really to understand the user needs and what kind of solution they are going to implement. And understanding the context, building the partnership and the common ground, and co-exploring the needs and the co-developing solution. And then, of course, it is really a cycle, because then we will look at what the data are needed, what kind of a modeling is needed, what kind of forecasting, which is a little bit of the work that you are doing in your tasks. And how the services should be delivered, and also well, another element is also that we are really, it is really important for us is all this information, all these products need to be operationalized, which means really produced in the routine mode. And at the end, also, it is important to evaluate if the services really reach the purpose, is fit for the purpose or not, or needs to be changed. So this is really the cycle that we are proposing for building these services. And also we identify the core elements that support, say, the uptake of these services by the energy industry. And you can see we have 4 elements here. And most of them actually covers the collaboration that is between WMO and your groups as they are developing. We are also aware that we need to create the capacity for developing these services, for meet the needs of the industry. And so we are deeply involved also in training activities that we run annually in different parts of the world, and depending on the demand or the opportunities, which means like sometimes there are specific projects that we can actually use the project as a vehicle for producing this training. And also this training are going to build a kind of a virtual library with the classes and the presentation that people can go back and rerun the class. So the first one happened last year and was organized in the framework of a Horizon 2020 project called Schlipf. And we had participant really mostly from Europe, but also from other countries. We are now starting a new training in Central Asia. It will start the last week of February. And next year we will also have another one in South America, because we have a project called Enandes, funded by the Adaptation Fund. I just wanted to highlight that for this, for example, training in Central Asia, we are really partnering with many institutions, like also the World Bank, WAMC, and also the United Nations Economic Commission for Europe. We are also involved in developing a portal, an interactive portal, and also an interactive atlas. And the portal is really going to be a gateway of, so has three elements, three main functions as here: a knowledge gateway, a networking and connecting between partners and members, and also there will be also this interactive atlas to be able to explore the climate risks of the energy subsector in order to build resilience and energy security. And also we will promote, the atlas will promote an integrative approach, so to be able also to identify complementarities among all the different renewable energy. So we are also connecting several agencies and partners to contribute with data, which is really important. And also I would like to be contacted by you if you think that you can contribute to this resilience atlas. And this is also about the resilience atlas, as we are considering it. So looking at the past data and also climate projection analysis. This is all starting now, actually, so I don't have a lot of more information on this. Here are other activities that we have with other agencies, including IEA, but in terms of, we had several webinars on resilience and electricity supply. We also are involved in the UN energy activity. We had also webinars with the International Atomic Energy Agency. And also, as I said, the capacity development activities with the World Bank and other partners. And here I just want to mention what could be the collaboration potential between WMO and your group. We just mentioned 4 here, so to contribute to publication, for example, to exchange external review of our publication, but also considering that we could have joint technical publication and guidelines on energy and meteorology. We also could have joint webinars and courses to, as I said, to increase the capacity to make sure that everybody has access to technological development that we have, say, in the global north, and especially transfer capacity and knowledge to developing countries. And also we can, as I said, contribute to this atlas and exchanging data. So I propose, as an immediate action to perhaps nominate focal points as people that can attend our respective meetings and can be the liaison of the 2 activities, and also to have formulate an MOU, a memorandum of understanding, where we formalize our interaction and maybe also formalize some specific projects and activity that we can work together. And this is the end of my presentation. Thank you.
Okay, thank you, Roberta. I think we'll have to come back to these MOUs and similar. At the moment, I had in mind to just keep that on an informal level, but let's see what exactly we can come up with in terms of collaboration. And once it's getting a bit more concrete, then there's always time to involve lawyers.
Absolutely, yeah.
Grüne?
Yeah, I think in consideration of the time, since we have been already in touch, I think it's a good idea to have some representatives that are official interactions and make the link so that we can participate in each other's meetings and then report back to the groups that would have interest in that information. So I think that's a really good idea on top of what we have already discussed. So that was just my confirmation that I think this is a really good idea, Roberta, and thanks for your presentation.
Thank you, Corina. And also I would say for us it's really important because we heard you say we need observation, we need good data. So let's work together because we might be able to actually improve our observation to serve your community. So these requirements need to be transferred somehow. And I think the linkages that we are establishing now could be really the channel to transfer this information.
Yeah, definitely. And I think the recommended practices that we have been working on now is preparing that link and also making sure that, and now I guess if once your draft version of the report is out, we can exchange and make sure that before ours is published, it's in line with what WMO is recommending. So we make sure that this is in line so we can get this aligned and really get forward in that topic because it's so important and it will become more important in the future.
Exactly. It will become more important.
Yeah.
Okay, on that note that we can probably all agree on that what we are doing is going to be getting more important in the future. If there's any more questions, then that would be now. Otherwise, the discussion about the state-of-the-art workshop for tomorrow might be deferred to tomorrow, where I can see that I need to do a bit more more active timekeeping because we have a lot of work streams and only 10 minutes per work stream. But maybe one thing, if you have if you have a possibility and would like to host a workshop, preferably near a major airport somewhere in Europe, then let me know tomorrow, and we can discuss when and where that workshop actually could be. I'm thinking, I was thinking about June in Paris, but I heard from George that the typical meeting room that I had in mind is currently being renovated, or otherwise used while other buildings are renovated. So that doesn't work out. So anything else? For 6 years ago, as mentioned, we were in Barcelona. That was very nice too. Anyone having an idea, please come forward with that tomorrow. So tomorrow, as mentioned, we're going through all the different work streams one by one. And essentially what we can get done there is a bit of a discussion on the framing of those work streams, what kind of actions we should be doing, and then a show of hands saying for all the participants, I would like to be involved here. And then we'd have some work stream lead who would take it further. So with that, sorry that we went a bit over time, but see you tomorrow, and thanks for the participation.
Thank you. Thank you.